Hello students, welcome to Meetu Maths classes. Your question is express the complex number z is equals to -1 plus root 2 iota in polar form. We know that if you are given a complex number in Cartesian form, then how can we convert it in polar form? To convert in polar form, a complex number must need two things. First is the modulus and the other is the argument of this complex number. R stands for the modulus of a complex number and theta is argument of the complex number. So we are just first try to find out these two quantities. So first take R. R is modulus of z and that is equals to square root of -1 square plus root 2 square and that is equals to root 3, and root 3 is the modulus of z. Now first of all try to find out the acute angle. Let alpha be the acute angle made by z with a positive x-axis. So let alpha be the acute angle, then alpha is equals to tan inverse of modulus of imaginary z upon real z, and that is equals to tan inverse of what is the imaginary part of z, that is root 2, and what is real part, that is -1. So tan inverse of root 2 is the acute angle made by this complex number with positive x-axis. Now let us try to find in which quadrant your complex number is. So since the first part, real part is negative and the imaginary part is positive, so our complex number, when real part is negative and imaginary part is positive, so our complex number is in the second quadrant, and in the second quadrant our argument is equals to pi minus alpha. So since real part of z is positive and real part is negative and imaginary part of z is positive, that implies z lies in second quadrant, and in second quadrant our argument will theta, argument of z is equals to pi minus alpha, that is pi minus tan inverse root 2. This is the argument of z. Now we can write our polar form. Polar form of z is equals to r is root 3 and cos of theta is pi minus tan inverse root 2 plus iota sine theta is pi minus tan inverse of root 2, and this is the required polar representation of your complex number.